As we go on looking at the classwork practice for 6.5, logs and exponential equations, read it carefully and then think of what tools do we have so that we can solve this. Well, this is an exponential form. Both sides, in a sense, we're going to convert to, let's say, natural logs. You could also use common logs, but so natural log of 8. Now we have an exponent. Once we convert it to its log form, we take that exponent and put it out in front here. X plus 3 equals the natural log of 1842. And again, what we're going to do is get rid of this, use a little algebra, divide this by natural log of 8, divide this side by natural log of 8. So now this is gone. I'll just use my eraser here. This is a 1. I can take away the parentheses. What do I do now? Well, I just take my positive 3, transpose it to this side as a negative 3. This would be the exact answer. Now what we want you to do is pause it, put this into your calculator and see what you get. And you want to round to 2 decimal places. So 0.615 would be rounded to 0.62. Going to drop that and make that one a 2. All right, pretty straightforward using the techniques that we've been working on. Now, looking at example 2 here, we see this very similar to the first one, but since e is involved, we're definitely going to use natural log. But the first thing I'm going to do is divide both sides by 3 to get rid of that 3 there. And now we're going to have e 2x to the negative 7, or negative 2, the exponent 2x minus 7 equals 9. All right, that makes it a little easier to work. All right, now I'm going to convert to natural log. Remember, that's going to be base e. We don't write that. And this side to natural log. So we're going to take our exponent, put it out in front. So we get 2x minus 7. Now, what did we say as a review? Natural log base e of e. What did we say that was? We said that was equal to 1. So this becomes a 1 that we don't write now anymore. And that equals natural log of 9. So what do we do now? Well, if you said you're going to transpose that negative 7 to this side and get a positive 7, that is correct. I'm going to erase this so it doesn't confuse us here. And then what do we do? Well, we're going to divide by 2. 2's cancel out, and our exact answer is this. Remember, this is a 9 here. So put that into your calculator and see what you get. And it comes out to 4.598. And we're going to round to 2 decimal places. So that becomes 4.60. All right, so we started off with some relatively easy ones. and hopefully you know what's going on. Now, this one is similar to the two that we've done, but a little more challenging because our exponent here on this side is a fraction. So let's set it up. It's going to be the natural log base e of e. We're going to take our exponent and put it out in front, 2x minus 5. And remember, all of this is going to become a 1 here. We'll leave it there for a moment. And then on this side, it's going to be natural log of 14. And our exponent now, we're going to put out in front here is 5x over 13. So you might say, oh, we got fractions here. How do we get rid of fractions? Well, if we multiply each term by the lowest common denominator, which is 13, that'll get rid of it. So we put like a little bracket there and go 13 times this is 26x. 13, and remember this is a 1 here, so I'm going to get rid of that so it doesn't confuse us here. Thirteen times -5 is -65 equals. Now 13 times this term, the 13's just cancel out, and we get 5x natural log of 14. Now the protocol we said to solve this was to get all our x terms over on one side. So I'm going to take this term, bring it over. So I have 26x. Now when we transpose it, it becomes a negative on this side. Natural log of 14 equals, I'm going to take my negative 65, transpose it, becomes a 65 on that side. So I factor out the x here, and I'll get x, and then in parentheses, 26 minus 5, natural log of 14 equals 65. So my question is, what do we do next? Well, we're going to isolate the x by dividing this on both sides. And you can keep that in parentheses or not. And put this into your calculator and see what you get. Now remember, this is the exact answer, but they often want an approximation, and that is 5.076 rounded to 2 decimal places is 5.08. Is that what you got? Now in example 4, it's very similar to what we've been doing, but now this side has 2 values for an exponent, and this side has 2. And this is e. So that's kind of easy to handle if we're going to convert it to natural log. So let's do that. Natural log base e of e. That's this part. We're going to take our exponent, put it out in front. 2x plus 1. But we know this is just going to become a 1. So keep that in mind. So what happens to this side? Well, it's going to equal. I'm going to take my exponent, put it out in front. 2x plus 3 in parentheses. And now the natural log of 76. Now, we know this is just going to be a 1, so I'll erase that. So this side is okay the way it is. But now we have to get rid of this parenthesis by multiplying this by this and this by this. So our next line is 2x plus 1 equals 2x times the natural log of 76 plus 3 times the natural log of 76. Now I could put these in parentheses or just leave them like that. Don't get confused. So you might say, what's our next step? Well, we had things like this already. We want to get all the x's on one side. So we have here 2x. I'm going to transpose this term to this side, where it becomes a negative 2x natural log of 76. And then that is going to equal 3 natural log of 76. I'm going to take this positive 1 now and move it over to this side as a negative 1. Okay. You want to be sure where everything came from, where everything is going to. So now we're going to factor out an x. And we're left with then, in parentheses, 2 minus 2 natural log of 76. And everything looks good. So what will x be? Well, we're going to divide this side by 2 minus 2 natural log of 76. And this by 2 minus 2 natural log of 76. Now, this would be the exact answer. What is the approximation of this? Put this in your calculator and see what you get. A negative 1.8002. They want us to round to 2 decimal places. So we go to the third, it's a 0. So this will be our answer. Approximation. Remember, this is the exact answer. In some of these, they will be asking for the exact answer. Remember, if you're going to put in ln for natural logs, you have to use the keypad, not type in ln. We reviewed that earlier, but never hurts to mention it again. So in example 5, read it, pause. We're using continuous compound interest. So it would be future amount equals the principal, Euler's E, and then rate times time. So substituting, our future amount will be 3,600. Our initial amount is 2604. Euler's E. Our interest rate is 4%, so that'll be 0.044. And what we don't know is the time. So pause, reflect, what tool can we use? Well, since it's in E, we can convert this to natural logs. First thing we want to do is get rid of this by dividing both sides by this. And to clean this up a little bit, now this part here is just 1, so I can erase that. Now we're going to take the natural log then of this side, and the natural log, which is of base e of e. We're going to take the exponent and move it out in front. So this is 0.044t. Now remember, this configuration is just 1, so we can leave that off. And this will be natural log of what we have here. Just not copying that again. Now, how do we solve for t? Pretty straightforward. Going to divide both sides by 0.044. 0.044. Now, this is not a log. This side is the log. So in your calculator, this again will become a 1. So a t. We're going to take the natural log of this divided by 0.044. So take a moment to do that. And when we do, we get 7.361 that we have to round to 2 decimal places. So we go to the third, and it's a 1. So our answer is 7.36 years. Again, having the knowledge of what formulas we're going to use and using the natural log, keeping in mind this becomes 1, there's kind of a shortcut you could take here, knowing the protocol and the shortcut. Okay, in example 6, as we look at it, it's pretty straightforward. It's in its expanded logarithmic form. So this would be the log, or the natural log, of x minus 5. Now, minus the natural log of this would be this then divided by x equals 6. Now, putting this from its natural log form into its exponential form. Well, what is our base here? Remember, it was e. So it'll be x minus 5 divided by x equals our base, e to the 6th power. So we've gone from logarithmic form to exponential form. But now we have to still solve for x. So we're going to multiply both sides by x. Here the x's cancel out, and we get x minus 5 equals e to the 6th power times x. Okay. Well, we want to bring our x's all over to one side. So we have x minus e to the 6th x equals a positive 5 on that side. So here we're going to factor out an x, and this is 1 then, minus e to the 6th equals 5. So we're going to divide both sides by 1 minus e to the 6th. Here, and then this side, 1 minus e to the 6th. Here, this just becomes x. And put that in your calculator, and what do you get? And you get this. Now, the question is this a reasonable answer for this? Well, if our x value is negative, putting a negative in there, you're going to end up with a negative log, which you can't have, and the same thing here. So for this one, you're going to have a box for what x is. Then you're also going to have a circle that says no solution. Well, in this case, that is your answer. There is no solution because this doesn't have an answer. And item 8 here, we have this equation. Again, what would the protocol be to solve? Well, again, since this is a natural log, base e of e, this will be natural log, base 15, and then this. Let's write it out. So our exponent comes out front here, 2x plus 5. Now, this configuration is just 1, so that stays like so. But this one is going to be our exponent's going to go out in front here. So this is going to be x over 5, the natural log of 15. Okay. Well, as we had one like this before, we have to get rid of that fraction. So we're going to multiply everything by 5. So this becomes 10x. 5 times 5 is plus 25. And then this is, the 5's cancel out here. So we just get x, natural log of 15. We've done some similar to this. We're going to take our x over to the other side. So this is 10x minus x, natural log of 15. Transpose this positive 25 over to this side as a negative 25. Factor out the x's here. We get 10 minus natural log of 15 equals a negative 25. And I think you see what's coming already. To find out what x is, we divide both sides by this. 10 minus natural log of 15. 10 minus natural log of 15. And let's see what you get. And I get a negative 3.4284. It goes on. They want us to round 2 decimals. So we go to the third decimal place. It's an 8. We're going to drop it and make this 2 a 3. And that is the answer. Now, are there any exclusions? No, this is what x is. That'll be okay. Looking at item 9 here. Again, we've had some like this. What do we do? This is in the expanded form. We want to put it in its condensed form. So log base 5 of x minus 4, and this is subtraction, so this is division, x minus 2 equals 2. Now, this is its log form. To solve it, we want to put it in its exponential form. So this would be the answer, or we could go base 5 to the second power equals x, Let's straighten that out here a little bit. Minus 4 times over x minus 2. There we go. Could have parentheses or not. Now, 5 squared is 25, so let's just change that. Now, we want to solve for x. So we're going to multiply both sides by x minus 2. And then on this side, that cancels out, and then we're going to distribute. So this is 25x minus 50 equals x minus 4. We want to put everything over to this side, so we got our x is over to this side. We're going to subtract an x from both sides. That's 24x. And we're going to add 50 to this side. So this gives me 46. I divide both sides by 24. And I get 23/12. Okay. Again, practice, study, working on your technique. Now, for item 10, as we look at it, we see it's in its log form. And this indicates multiplication of these. And in a sense, if we just divide everything by log base 2, we end up with x plus 5 times x minus 4 equals 4x minus 10. Just a little bit of algebra. We're going to FOIL this side and get x squared plus x minus 20 equals 4x minus 10. Transpose this to this side. This gives me x squared minus 3x. Now we're going to add 10 here. Gives me a negative 10 equals 0. Factor this. X, 5, 2. Our middle term is negative, so this needs to be a negative and plus. So here we get x equals a negative 2, or here x equals 5. Now here it's a case where we have to check whether our values make it a true statement. Now if x is a negative 2, here we would have a value of 3. That would be okay. But here if x is a negative 2, with our negative 4 there, that would make this a negative log. So we have to reject that as a possible solution. So what is the only solution? And it would be x equals 5. If you were to put in there x equals negative 2 comma 5, they would count that wrong. You have to test to see if the values you get make our log a negative. If it does, we reject that. Okay, almost finished. For item 11, it's not continuous interest, but just compound interest, where our n here is going to be monthly, so that's going to be 12. Our rate is going to be 5.2%, so that goes in as 0.052 divided by 12. And then we know our exponent here is going to be 12 t. And we know our initial starting was 5379. Oh, that's actually another 5. I misread that. And then the future amount is going to be 6160. Okay. So we've done some piecemeal substitution. Let's write it completely down here. This looks a little better. Okay, so we're going to take the natural log of this. I've divided that to get rid of it on this side. And the shortcut is we're going to do the natural log of this, but this exponent now comes out in front. And what will t be? Well, t is going to equal all of this so that it looks something like this. So this divided by this, remember that 12 went out in front here, and we had this. That's what t equals. Now this is the exact answer, and they're asking you to round to 2 decimal places. So in our third decimal place, I got a 9. So this is 1.92 years. Again, the tedious part is putting this into the calculator. But you have to put this in like one big set of parentheses, and then this, and then divided by, and then this, and then another set here, and then calculating that, it gets rather tedious. I had to do it twice to get the answer. I guess I typed in the wrong information one time. Now, I'm going to put in one extra example. We'll call this one number 12 here, where the pH formula of something, hydronium ions, is equal to the negative log of some value, and that's the concentration of this hydronium ion. Well, it gave it as 7.7 times 10 to the negative 5. And you want to round your answer to 2 decimal places. Find out what the pH is. So it's just going to be, in your calculator, negative log, and then a parenthesis comes up. Just put this in, times 5 negative exponent, negative 5 power, close parenthesis, and hit enter and see what you get. Well, I got rounded to 2 decimal places, 4.11, which is acidic. Remember, we said 7 was neutral. Anything above 7 was alkaline. All right, long enough, and you'll have your practice and certify. Hopefully this is helpful.